Amazon's cart runs on NoSQL at over 100 million requests a second. Your bank still runs SQL. Both are right. And by the end, you'll pick correctly with one question. SQL databases like Postgres and MySQL store everything in tables. Think spreadsheet. Every row has the same columns. Here's Maya. She's a row. ID 7, a name, an email. Every user has exactly that shape. That shape is called the schema, and the database enforces it. Try to insert a user with no email. Rejected. Strict sounds annoying. It's actually a promise. Your data stays predictable forever. Maya's orders live in a separate table linked back to her by ID. At query time, you join the two tables together. NoSQL document stores like MongoDB flip this. Maya becomes one JSON document. Orders nested right inside her. No fixed schema. One user document can carry fields, another doesn't. Perfect when your data's shape changes every sprint. The cost. Relationships get hard. There are no joins to lean on, but storage shape is the easy part. The real fork is what happens when two things must change at once. Say Maya sends her friend $100. That's 2 writes. Subtract from her balance, add to his. What if the server dies between them? Money just vanished. SQL solves this with transactions. Both writes commit together or neither happens. That's the A in ACID, atomic. SQL also promises consistency. The instant a transaction commits, every read sees the new balance. No exceptions. Most NoSQL systems traded that away for speed. They copy your data across machines and copy sync a beat behind. That's eventual consistency. A read can catch a replica mid-sync and see stale data for a moment. Totally fine for a like count, catastrophic for a bank balance. Modern NoSQL has bolted transactions on. MongoDB supports them now. But ACID is SQL's home turf. So why would anyone give up those guarantees? Because of what happens when one machine isn't enough. SQL's classic answer to load is scaling up. Buy a bigger machine. It's like hiring one superhuman cashier. Works great until the line outgrows any cashier money can buy. NoSQL scales out instead. Split the data across many cheap machines. That split is called sharding. It's opening more checkout lanes. Each lane handles its own customers, and you can always add lane 7. Documents shard beautifully. Maya's document is self-contained, orders inside. So one shard answers everything about her. Now try sharding tables. Maya's row sits on one machine. Her orders land on another. Every join now crosses the network. That's the slow, painful part of distributing SQL. This is exactly Amazon's trade. Cart lookups hit one user's data by ID, no joins, spread across thousands of nodes. But before you pick a side, one twist. NoSQL isn't a single database at all. NoSQL is a family of 4, and each one stores Maya differently. Documents you've already met. MongoDB keeps Maya as one rich JSON blob. Key value stores like Redis go simpler. One key, one value, nothing else. Blazing fast lookups. That speed is why sessions and caches live there. Wide column stores like Cassandra look like tables but shard like documents. They're built to swallow millions of writes a second. Sensor readings, message history. Graph databases like Neo4j make relationships the data itself. Maya links to friends, friends link onward. Friend of a friend queries take one hop here. The query that murders SQL joins. Match the family to your access pattern. Which brings you back to that one question. Ask this. Is my data mostly relationships or mostly lookups? Money, inventory, bookings, data tangled in relationships that must always be correct. That's SQL territory. Carts, sessions, feeds, logs, grab one blob by key, at huge scale, shape, changing often. NoSQL territory, still unsure? Default to Postgres. Most apps never outgrow one solid SQL box. Postgres even stores JSON columns, so you get document flexibility inside a relational database. And real systems cheat. They use both. SQL for orders, a NoSQL store for sessions and caching. Here's the whole video in one sentence. SQL is strict, relational, and correct. It scales up. NoSQL is flexible, key-based, and fast. It scales out. Relationships and correctness. SQL. Scale and flexibility. NoSQL. In doubt, Postgres. If this saved you a future migration, subscribe. More systems explained like this, one picture at a time.